Hey folks, here's a new video on Ohm's Law. We're going to get to the formulas in just a little bit, but we have to do actually quite a bit of understanding of what the different letters in the formula mean before we can go and just start calculating. Now there are some things that you'll already know, so this will be a bit of a review and maybe you'll learn some new things. So circuits can either be opened or closed by a switch. Okay, so this is the schematic diagrams that we talked about previously. So here is a battery. These are wires. This right here is a switch. In this case it's open and in this case it's closed. And here is a light bulb. Okay, so electrons, they flow from the negative end to power the load, whatever it is. In this case, it's a light bulb, and then return back to the positive end. So this right here is an example of an open circuit. So that means that it's off. A closed circuit means that the light bulb is on. The electrons are flowing and powering what needs to be powered. So there are three really important aspects to circuits. The first one that we're going to talk about is the current. Now we call this I. Now ammeters, these are the measuring tools that measure the current. The ammeters only record the huge number of electrons passing through the conductor. We call this the current. So 1 coulomb, this is just a unit of measurement, like we have liters or grams or meters or miles or kilometers. This unit of measurement is called a coulomb. 1 coulomb equals 6.25 billion electrons. So that's 6.25 times 10 to the power of 18. That means that there are 18 zeros. That's a huge amount. That's why it says right here, huge. The units for currents are called amperes. And we say A. So 1 coulomb per second is 1 ampere. So just to kind of give us a sense of how powerful current of electricity can be, 0.8 amperes, that's the charge that's needed to light a 100-watt light bulb. However, something that's way less than that can actually kill you. So at 1.2 amperes, severe burns happen, your heart stops, your lungs stop. In between 0.2 and 0.02, that's the let go threshold. That's the threshold where the current is so strong that the only way to not make our muscles contract is to have the current stop. So that's actually a pretty significant threshold because that is kind of like the deadly threshold. And even at 1/10 of that, so 0.02 amperes, your breathing is impacted and your muscles start to contract. And at 1/10 of that, so 0.002 amperes, you can actually feel your muscles tingle. So electric currents are no joke. The next thing that's really important in the Ohm's law kind of formula is voltage. So we call voltage V. It takes energy to or work to free electrons. Sorry, that's kind of, there we go. Free electrons by the chemical reaction of a cell. Energy is stored in every single electron. The energy contained in an electron is called the electric potential. So the voltage, okay, so like on different cell batteries, you see it's 1.5 volts or 9 volts or whatever. So the voltage is the difference between the electric potential at the negative and positive electrodes. So as electrons move through a circuit, they lose all of their potential energy. So say you're making a little circuit with a battery and a light bulb and some wires. That means that the electron leaves the battery. Okay, the electron leaves the battery and then powers the light bulb, and then the electron has lost all of its the electron loses all of its potential energy, and then it goes back to the positive electrode, and then it goes through the battery again, and it powers up to the same voltage, and then it does the exact same thing again. So the units they're called volts, and like we said, we called that V, and they're measured by something called a voltmeter. So remember that crazy big number, a coulomb, so which is 6.25 times 10 to the power of 18, or 6.25 billion billions. So the energy per 1 coulomb of electrons is 1 volt. That's kind of nice. Even though you have to kind of know the crazy big number, the 6.25, remember 1 ampere and 1 volt, that's pretty good. And just to give us kind of a sense, so 550 volts, that's the potential energy of a power station. So as electrons leave the power station, they leave with 550 volts each electron, but when they come back with 0. So 120 volts, that's the potential energy of a home wall outlet, just a regular one, not necessarily, just a regular one. And then 9 volts is a smoke alarm battery, so that's one of these rectangular batteries. And then 1.6 volts, that's the voltage in a AA battery. So the AA battery looks like this, and the 9 volt battery is that square one. So let's just go through this kind of the life of an electron a little bit. So this right here, let's call it an example of a 5.5 volt battery. So that means that the potential energy of this is E minus, it just means electron, that's just a short form for it. So the potential energy in an electron in each electron is going to be 5.5 volts. So when, so with voltage, we know that this is going to be 5.5 volts. And this is right here, the electric potential difference. So this right here, this metal rod that kind of runs the height of the battery, this is called our kind of electrode, and it has a positive end and it has a negative end. Okay, so this right here is our positive electrode, and then this one right here is going to be our negative electrode. So this is the negative end and this is the positive end. This right here is it's an electrolyte paste. And it helps in charging up the electrons. So electrons move from the negative end and go through. They power the light bulb, and then they lose all of their energy. So it goes from 5.5 volts in the electron to 0 volts, and then it goes back here. So it starts out here as 5.5 volts. And then as the electron goes through, it comes back with 0 volts. So the difference between 5.5 and 0, if you go 5.5 minus 0, it is 5.5. So electrons lose all of their energy as they move through things. So you can have all kinds of different things. Sometimes we call these things resistors. Which brings us actually to our last important piece of the Ohm's law kind of definitions, a resistor. So a resistor is an electrical device in a circuit that takes potential energy away from electrons. It's called resistance. So the electric symbol is R, and the unit is called the ohm. So that's why Ohm's law. And it's this it's the Lululemon symbol. But this is the unit. So like for example, a schematic symbol could be this is an example of a resistor. Okay. Or we can have this type of a diagram for a resistor. We call this one an R1. Oh, sorry, this one an R2, and then this one an R1. Okay, so the loss of potential energy over a resistor is called the voltage drop. If you take a voltmeter, and actually measure before a resistor and after a resistor, that's where you notice that the volts are significantly different. Resistors sometimes reduce the energy of a circuit for safety reasons. Oh, so any resistor that takes the energy and converts it for actual use is called a load. So an example, like I've been saying a lot, is like a light bulb. So sometimes the load is going to be like a fan. This is called mechanical energy. And sometimes it converts it into heat. This is called thermal energy. So remember, a load is a resistor that converts energy, and a resistor, it lowers energy and it can be removed as heat.